All right, guys, let's get started. Before we jump into any of the problems, I want to remind you of the basically factoring methods or factoring weapons we can use in order to factor different types of polynomials. So let's throw them down here. The first one that you should always attempt to do is GCF. Okay, so that's your first weapon you want to go to battle with when you're dealing with these polynomials. Remember, GCF is we're trying to divide out the biggest number. So I'm going to just put a little note here. We are trying to divide the big number or variable. Okay, so the next weapon we have is the X method. Okay, what the X method is you have to have the ABC pattern. Okay, this is called the quadratic pattern. A, B, C. All right, what it is when you have the ABC pattern is your A number has a variable to an even, a variable to an even power. So if you think about this, you'll have x to an even power, okay? Your second term is going to have a variable, we'll call it x, to half of that power. All right, it's pretty easy to see once you get it. And then your c is your constant, no variable. So it's just going to be a number by itself. So an example of the ABC pattern or quadratic pattern, and I'll put that up top, quadratic. Okay, is example number 1 because the a value is 1. All right, that's the key. So not only does it have to have the quadratic pattern, which is an even power, half of that power is the middle term, and then a constant at the end, a number without a variable. On top of that, the number with the even highest power should be 1. Okay, so if you look, example number 1 is the X method. It has an even power. Half of this power is 2. We have that here for the second, our B value. And then we have a number without a variable. Okay, on top of that, the number in front here is 1, which we need. Okay, so that's when you use the X method. The snowflake method is exactly the same thing. You need that quadratic pattern. When I talk about quadratic pattern, I'm talking about the powers. So exactly the same thing. We need our A and B and C pattern. So we need our variable to an even power. Our second term or our B term has to be half that power. And then we have to have a constant, a number without a variable. The only difference now is our A value is not 1. Okay, an example of this would be number 4. It has the pattern. 4, half of 4 is 2, and then no variable, and our number in front is not 1, it's 3. Okay, so just you'll see the patterns pretty simple. It's just you got to start recognizing these patterns. Okay, and the last thing we have is factor by grouping. And the way you recognize this guy is it has 4 terms. Okay, and this is called factor by grouping. This is where you split. Okay, so you're going to split your example. So I'll show you what it looks like, but to do this, it's 4 terms. An example of that is number 5. Okay? So these are your weapons. GCF, you always want to try. These other ones, you got to choose which one it will work for. For example, factor by grouping is not going to work for this guy. Factor by grouping is not going to work for this guy, but factor by grouping will work for this guy. The snowflake, okay, we're not going to use it for this guy, but we can use it for this guy, and I will explain. Okay, so let's jump into number one. Let's do that. We want to check for GCF. Is there a number besides 1 I can divide? And the answer is no. Do they all have the same variable? And the answer is no. So GCF is out of the question. I can't divide a variable or a number here. So now I got to choose which one of these other 3 options I can use. And I know it's a quadratic pattern because my power in front is even. My second power is half of that power, so it's 4, 2. And the last thing I want to check for is what's the number in front of my highest powered variable, and that number is 1. So since I have a 1 here, I'm using this method. Okay? So here we go. If you remember, A times C on top, B on the bottom. A times C is 1. Our A value is 1. Our C value is 12. Again, our ABC pattern. A, B, C. Okay? So it's negative 12 here. Our B value is positive 1. So we have to figure out what multiplies to negative 12. That adds up to 1. And that is going to be 4 and negative 3. If you do this math, when you multiply, it gives you negative 12. When you combine these, it gives you positive 1. All right, once we have our magic pair, we put it in our template, which is turn it into factored form, which is 2 parentheses in this case. And now our variable goes first, but here's the difference. We're going to split the power of 4. Okay, we don't have a power of 2 here, it's a power of 4. So we got to split the power of 4 evenly. So it's going to be x2, x2, and then we put positive 4, negative 3. Okay, and we're done factoring. All right, later on we're going to talk about how this might factor even further. We got to check, can these little polynomials, so you have actually 2 polynomials here, can they even factor further using some of these methods? Okay, for now, that's all we have. It's factored, we are done. All right, jump over to number 2. If you look at number 2, there is no GCF here. So GCF is out of the question, but it's also not in our ABC order, okay? Right off the bat, it doesn't look like our ABC order because we have A, we are missing the half power in the middle, so we're actually missing the B. Put a little question mark, we're missing the B, but we do have the C. Okay? If you recall, you can rewrite this into a quadratic pattern. So that's what I'm going to do. It's going to be 16 x to the 4th. And we are missing the B, which means when you're missing something, it's just a 0. So I'm going to put positive 0 x to the 2nd. Remember, we want that pattern. Highest power is even. Half of that is 2. Okay, and then we bring in the negative 81. All right, now we know we got to use snowflake. Okay, because we have A, B, C, but our A value is not 1. So this is the snowflake method. So let's do the snowflake. We're going to go A times C on top. So 16 times negative 81, that's negative 1296, I believe. Let me confirm that. I'm doing it in my head. 81 times 16. Yep, 1296. And then our B value is going to be 0. We had to write that in. And now what we're going to do is we got to fill in this spot. So we're going to take 16 and 16, but we're going to split the x 4. So it's going to be x squared, x squared. Okay, now we have to figure out our magic pair here. What multiplies to negative 1296, but we'll add to 0. Okay, so it's actually pretty simple because we know in order to add to 0, we have to have the same numbers here but different signs. So I know 36 and negative 36 will work. Okay, as the numbers get bigger, these get a little more difficult because of your multiplication. So 36 times negative 36, punch that in your calculator, you get negative 1296. If you add these together or combine these, you get 0. So my magic pair is here. Since we're using snowflake, we want to divide by a common factor. Okay? And the common factor here, believe it or not, we can reduce by 4. So if I reduce by 4, 16 divided by 4 is, we get 4x squared on top. Okay. 36 divided by 4, we get 9 on the bottom. Okay, and we actually could do the same thing on the other set. Remember, you want to reduce here, so we're going to reduce by 4. That's the biggest number that can divide 16 and 36. So over here we get 4x squared on top, and here we get negative 9 on bottom. So once you have that, we are done factoring. Okay, so we get 4x squared plus 9. And then we get 4x squared minus 9. Okay. All right, here's the kicker. And I mentioned it in problem number 1. If you look at this, this actually is the ABC pattern again. So if I rewrote this guy, it's 4x squared. We're missing the b value. So b plus 0 x for my b value plus 9. Okay? So if I was doing these problems, I had to move that out of the way for you really quick. So if I was doing these, this is actually the snowflake, the snowflake pattern. It has A, B, C, and it's not 1. So if we were doing this, we would do the snowflake pattern again here. 4 times 9, that's 36. That's A times C. Our B value is 0. Okay. We're going to go 4x here and 4x here. And again, this is the quadratic pattern because it's power of 2, even. Half of 2 is 1, and we have that, and then our constant. But the problem here is nothing really adds up or multiplies to 36 that adds up to 0. Okay? You might think 6 and negative 6, but when you multiply this out, 6 times negative 6 is actually negative 36. So actually nothing works for this guy. So this cannot be factored anymore, which means we don't have to do that for this first guy. Okay? He's already completely factored. But if you notice, this guy is very similar. If we did the same thing for the second term and we put in our b value to make it a quadratic pattern, okay, just like we did there, we would use snowflake again and watch what happens. If I use snowflake here, 4 times negative 9, negative 36. My b value is 0. That goes here. We have 4x, we split up the x here. And now what multiplies to negative 36 that adds up to 0? Well, this actually works. Okay? So because it works, that means we have to factor this further, which I am doing with the snowflake method. So this is not factored all the way. I'm going even further. So it's the same process. You just have to look for it. So now I want to divide here. I'm going to divide by 2. Okay, I'm going to divide by 2 here because that's the biggest number that divides 4 and 6. And what we get is this. This turns into 2x on top. This turns into 3 on bottom. 2x on top, negative 3 on bottom. So my final answer would be this. This guy did not change. We couldn't factor him. None of the numbers worked out. So we leave 4x squared plus 9 exactly how he is. He couldn't factor. But this guy, as you can see, actually worked out. Once we put him in the quadratic pattern, we were able to do the snowflake method, and he turned into 2x plus 3 times 2x minus 3, which I got from here and here using the snowflake method. Okay? This is actually your final factored form. As you can see, it's a lot of work. The hardest part, guys, is not the methods. The methods are easy. The hardest part is recognizing. Would have been able to see that, oh, I can factor this even further? Would you have known this was the snowflake method? Okay? And that's the kicker. You got to be able to see all this stuff through here. All right? So keep that in mind as we go forward. Okay? All right. All this stuff got put in. Okay. All right, so let's jump over to the next page. Okay. It's quite a bit to take in. I'm not expecting you to know it right off the bat. This takes a while to master. But the key is you got to know these methods. All right. So I want to jump in and I want to do an example of factor by grouping. Okay, so let's jump in over here. All right, we're going to jump into number 7. Okay, and if you know, we actually have 1, 2, 3, 4. This guy has 4 terms. Okay. Because he has 4 terms, we automatically know we're going to do factor by grouping, which was explained in the video, but I'm going to explain it now. Okay, factor by grouping only works when you have 4 terms. So what you want to do is you're going to split this into 2 problems. So I'm going to put a line right down the middle here. Okay, notice this sign goes with the second half of the problems. If it's negative, it goes with the second half. Is it positive? It goes with the second half. Okay? So you want to split it like that. So what we're going to do is very simple. We're essentially just going to do GCF for this. We are going to ignore this side for now. Our goal is to do GCF. So we're looking, what's the biggest number that can divide 10 and 5? So if you remember doing GCF, we make a list. I'd like to choose the smallest number to make a list from. So it's 1 and 5 can divide 5. So we go 1 and 5. And then if you want to make a list here of what can divide 10, it's 1, 2, 5, and 10. Okay? Of those 2 lists, what's the biggest number they have in common? It's 5. Okay? So that means my GCF here is 5. Okay? Now we look at the variable. Do they have a variable in common? And they do. They have n's. So we want to pick the lower powered n. So the lower powered n is n squared. Okay? Once we have our GCF, we're going to divide these 2 numbers by our GCF. So we're going to divide by 5n squared here and divide by 5n squared here. Okay? So 10 divided by 5, that's 2. N to the third, take away 2 n's, that's going to just be n. Negative 5 divided by 5, that's negative 1. N to the second, take away 2 n's here, that's cancels. This goes in parentheses, and our GCF goes in front. Okay, so we GCF there. Now we're going to do the same process over here. We want a GCF here. Okay? Here's a rule I have. If your first number is negative, then your GCF is going to be negative. Okay? So my first number is negative 14. That means when I write my GCF, let's write it as a negative number. Okay? So let's do GCF here for this. GCF for the second half. I'm going to make a list of things that divide 7. 1 and 7. Can I choose the bigger guy in your list? Can 7 divide 14? And the answer is yes. Okay, so that means my GCF for this is negative 7. Because our first guy is negative, we want to make our GCF negative. Do they have a common variable? N and no n. So there is no n in my GCF. Now take your GCF and divide away. So we're going to divide by negative 7. Negative 7. Negative 14 divided by negative 7. That's actually positive 2. Bring down the n. 7 divided by negative 7. That's negative 1. And then we put our negative 7 in front, our GCF. Okay, here's the key to factor by grouping. Once you GCF both of them, the stuff in parentheses should match exactly the same. Signs, everything. So if you look, we have 2n minus 1, 2n minus 1. If they are exactly the same, you did it correctly. If something is off, you factored incorrectly. You got to redo the GCF. Okay? There's a lot of times the signs will be off. For example, if I didn't factor by a negative 7, the signs would have been off here. And all you would have to do is say, oh, my signs are, it's the same thing, but opposite signs, I better switch the sign here. Okay? So make sure everything's exactly the same. Once, not everything, but the stuff in parentheses is exactly the same. If you have that exactly the same, we can move on. And what we're going to do is we're going to regroup these guys. Okay, and what does that look like? Your GCFs go in one group. So 5n squared, and then we have a negative 7. So that's going to go in its own factor here. So the GCFs go together. Careful with your signs. And then the matching parentheses, we just have to write them down once. Because they're twins, we just write them down once. You don't have to put a power of 2 or anything, just 2n minus 1. Okay? All right, and we are done factor by grouping. But something you should notice, this has an even power here. Okay? So again, this is why these can get really crazy. We got to notice, shoot, this might be the quadratic pattern. So I'm going to rewrite this just to check. Because you always got to check, is this a quadratic pattern? So I have an even power. I'm missing the b value here though. So it's going to be plus 0n. There's my b value. And negative 7. Okay. So this looks like the snowflake method. So it's A, B, C. And we have an a value that's not 1. So we're going to try the snowflake method here. It may or may not work, but we got to try it because we've got to factor as much as possible. So we're going to go A times C here, and B goes down here. So A times C, 5 times negative 7, that's going to give me negative 35. My B value is 0. My 5n from the front gets split here. So this 5 goes here, in here, and then the n gets split. And now you have to ask yourself, can you think of something that multiplies to negative 35 that adds up to 0? And what you'll notice is the answer is no. There's nothing that multiplies to negative 35 that adds to 0. So even though we checked it, it didn't work, which means this is my final answer. Okay? You might be asking, why don't we do the snowflake here? Remember, your highest power here has to have an even power. If you notice, n is a power of 1. Okay, this guy was a power of 2. He could be the quadratic pattern. This is not the quadratic pattern. So that is factor by groupment. Okay, let's do number 11. All right, and then we will call it a day. So number 11, we are going to factor 2 different factors. This guy, and then we'll factor this guy, okay? So let's ignore this guy for now. Let's go ahead and look at this. It's the quadratic pattern, as we can see. And based on our rules, it's actually just the diamond, okay? Quadratic A, B, C, and our A value, the number in front of our variable is 1. So 1, A times C is positive 8, so that goes here. Our B value is negative 6, that goes here. What multiplies to positive 8, that adds up to negative 6. Okay? So if you multiply negative 4 times negative 2, that's positive 8. Negative 4 combined with negative 2 is negative 6. So our magic pair is negative 4 and negative 2. So once we find our magic pair, we're going to go ahead and put it in our template. Split the 4, so it's 2 and 2. Negative 4. Negative 2. Okay, so we have that. We're going to come back to this because if you notice, these are quadratic patterns. We might have to do this again for these guys. All right, let's jump over here. So this is A, B, and C. So it's a quadratic pattern because we have higher power is even, half of the power here, and then no power at all. Okay, so it's even, but we have a number in front, and it's going to be snowflake. All right, so now we fill in the snowflake by doing A times C, which is 5 times negative 12, and that gives me negative 60. Okay, our B value is negative 11. And then we're going to go ahead and write the 5b here and the 5b squared here. 5b squared, 5b squared. We're splitting up that first guy. So 5b squared, 5b squared. Okay. So now we have to figure out what multiplies to negative 60 that adds up to negative 11. And if you're good with calculators and multiplication, you should find this pretty easily. It might take a while, but it's not too bad if you take your time, okay? So the thing that multiplies to negative 60 that adds up to negative 11 is negative 15 and positive 4, okay? So it might take you a while, but it's doable, all right? So now we want to go ahead and divide here. What can reduce here? It's obvious we can reduce by 5. So we're going to reduce by 5. Okay, Over here, we're not reducing by anything. So let's go ahead and reduce by 5 or divide by 5. So 5 divided by 5, that gives me 1b squared. 15 divided by 5, that gives me -3. Okay? So that means my magic pair for this guy, or my parentheses look like this, is going to be b squared minus 3 and 5b squared plus 4. Okay, so if you notice, we have all possible quadratic patterns, okay? So I'm going to give you a quick hint on whether or not to know, can I factor these guys even further, okay? The only ones that factor, when you have a power of 2 in front and you only have a number at the end, so you basically have two terms, a power of 2, is when you have a b squared or a squared and the number you have is actually an even square root. For example, the square root of 4. The square root of 4 gives you a perfect number. It gives you 2. Okay? So if you look, we have a quadratic, power of 2, square rootable number, and this guy also has to be negative. So it has to be subtraction. So this is the only guy that's going to factor more. Okay, and I'll show you in a little bit how we do that. This guy has all the right criteria. The only thing that's the problem is the square root of 2 is not an even number. It's like 1 point something something. Okay, so we can't factor this anymore. How about this guy? Everything's good. We got a subtraction here. We're good. But here's the problem. Square root of 3 is not an even number. Okay? How about this guy? Everything looks good. 4 is square rootable. We can square root 4 because it's 2. But the problem is we have an addition sign. We need a subtraction sign here. So the only one we can factor further is going to be the first guy. Okay? So let's factor the first guy further because it's a quadratic, power of 2. He's square rootable. He's square root of 4 is 2, and we have subtraction. So let's turn this guy into the quadratic pattern. So I'm going to do the work here. So it's going to look like this. B squared plus 0b minus 4. This is snowflake method. Again, that's a B. I know it looks like a 6. Snowflake method, or sorry, diamond method, X method. A times C is -4. 0. What multiplies the -4 that adds up to 0? -2, +2. So this guy turns into b minus 2, b plus 2. Okay? So what does my final answer for number 11 look like? I'm going to write it here. Okay? So b squared minus 4 turned into this. So let's write it as b minus 2, b plus 2. Okay? So that's what happened in this guy. The rest of the guys, they're factored completely. We can't do anything more. B squared minus 2. Good. B squared minus 3. Good. And 5b squared plus 4. So I know it's crazy, but number 11, this is our final answer. All right, guys, let me get you out of here. I know it's been a long session, but there's a lot of information here, okay? Practice these factory methods. Please do these. Check your work on the answer sheet and go from there. All right? Let's get you your check-in code.